Hello students, let's welcome to our YouTube channel Physics for UG. So in this video we shall discuss about Fresnel's biprism. So what is Fresnel's biprism? Basically it is a method which is used to obtain coherent sources in order to produce sustained interference. That means we need to find sustained interference and also we need to find the coherent sources to obtain the interference pattern. So this is basically the method of division of wavefront method. Okay, let's understand what is Fresnel's biprism. So first listen, there is a word bi. So bi means two. So biprism means there are two prisms used in this system. So it is a device consisting of two prisms of very small refracting angles placed base to base to obtain two coherent sources to produce sustained interference. So in this figure there are two prisms, there is one P1 and there is P2. So this one is the first prism and this one is the second prism, and both the prisms are placed base to base. That means their bases are in contact with each other. And let's analyze what is the process and how the interference pattern and how the interference occurs in this Fresnel's biprism. Light from S is a source, gets refracted by prisms P1 and P2. This is S. So light from S gets refracted from prism 1 and then from prism 2, thereby producing virtual images S1 and S2, which can be taken as two coherent sources producing interference. So S is actually the source of light from which we get two rays, of one ray towards prism P1 and another ray towards prism P2, and by the two prisms the two images are, one is S1 and another is S2. So S1 and S2 are the two virtual images because they the rays actually don't meet here, they have produced backwards. That's why these are the virtual images. So the virtual images are S1 and S2, which can be taken as two coherent sources, and these two parts are the coherent sources and they produce interference. So light beams from S1 and S2 strike the screen in the region ED and FC respectively. Look at the figure. So from this S1, the region of light is this part is E. Look at the figure, this part is E and this part is D. So from S1 the light falls on the region from in this part. Similarly from the part S2 the light falls on G part and another point is F part. So consequently the light from S1 falls in the region E to D, and for the point source S2 the light falls on G to F. So here, so from these two figures, EF is the common region where both the beams can be found. So what is the common region? This EF, the darkened part, the lined part, this part is the common part. Okay, this is the common part, and therefore the interference pattern can be observed in the region EF. As this is the common part, so the two rays from S1, one due to S1 and other due to S2. This is the common part. Common part is the EF, and the two common parts, and the common parts for both the waves, they produce interference pattern. So what will the pattern, how they occur? Let's look at determination of wavelength lambda. So biprism method can be used to determine the wavelength of light. Fringe width beta of the interference pattern is given by beta equal to lambda into capital D by small d. That is already we have discussed in Young's double slit experiment. So what is lambda? So keep lambda here and D take to the left side and D to the left side. That will be beta into small d by capital D. So this is, after cross multiplying we get lambda equal to beta into capital small d by capital D. That is lambda. So there is another way to determine the small d value. What is small d? Small d is the separation between the two sources S1 and S2. So look at the figure, this is S1 and another part, this is S2, this part is D, this is the middle part. So here C is symmetrical, the point C is symmetrical with respect to S1 and S2. D can be calculated by using displacement method. A convex lens is placed in between the biprism and the screen. This is called biprism. This P1 and P2 are called the biprism. This P1 and P2 are called the biprism because it consists of two prisms which are placed base to base. Their bases in contact with each other. Okay. It will be observed that for two positions L1 and other position L2 of the lens, the images of S1 and S2 can be focused on the screen AB. Listen, this is S1, this is the prism 1, this is prism 2, and this is lens and this is lens 2. At a single time, we use only one lens at a time. We use only one lens. This is absent, this is present. So we get the image at the point at the screen AB. So later on, what to do? This L1 is removed. This part is removed and this part is present. Then we also get another image on the screen. So here it will be observed that two positions L1 and L2 of the lens of images, the images S1 and S2 can be focused on the screen AB. Because S1 and S2, the image can be focused on the screen AB. Let X and Y be the distances between the images when the lens is at L1 and L2 respectively. If the lens L1 is present, there will be two images, one for S1 and other for S2. So if the distance between the two images is X, if L1 is present, if this one is present, okay, and Y is the distance, between the images when the lens L2 is present. And again, what to do? L1 is removed, and L2 is present. So in that situation, there will be two images, one for S1 and other for S2. Suppose this distance is Y. Once again I am repeating, X is the distance between the two images when lens L1 is present, and Y is the distance between the two images when only L2 is present. Remember, at a time only one lens is used. So X is the distance between the two images and Y is the distance between two images when L2 used, and X is the distance between two images when L1 used. So this formula will be D equal to XY root over. What is D? D is the separation between the two S1 and S2. So D equal to XY root over. Thank you. This is all about Fresnel's biprism, and by using this Fresnel's biprism, you can find the wavelength lambda of the light, and S1 and S2 are the two coherent sources which can be produced, which are produced by the virtual images of the two prisms, that is P1 and P2. And also we can determine the d, small d value. Small d is the distance between the two slits, the two point sources S1 and S2. Thank you.